Hi guys, good evening everyone. Good evening guys. How are you all? I hope everyone is doing well. So today we are going to discuss one of the theory which helps us to understand about bonding in coordination compounds, which is valence bond theory. It's a very important theory to understand the hybridization of the coordination compounds and yes, it's really important for us to know few of the characteristics regarding the complex, like what is its hybridization, geometrical shape, the magnetic property, right? So all those things you can find it out with the help of this theory. Okay, so before starting with this concept, I quickly want to introduce myself to all the new learners. So, guys, I'm Manisha Rani, your chemistry educator at Unacademy. I have enriched 5 years of experience in both online and offline teaching. I have completed my master's from NIT Warangal and bachelor's from Delhi University. I have cracked many of the very known exams, that is IIT JAM, CSIR NET and GATE. I have given best ranks through my students in NEET as well as JEE, and I'm a plus verified tutor, guys. Now, talking about the topic, guys, which is nothing but valence bond theory. So, what you can understand regarding valence bond theory? So, basically, remember, guys, one of the valence bond theory we learned in where in coordination compound right now we are studying, but in one of the chapter in 11th standard we have studied valence bond theory. Anyone wants to name in the comment section in which chapter we studied in 11th standard about valence bond theory? Tell me, guys. Yes, we discussed about it in chemical bonding. Same way, now we are learning here in the coordination compounds, and in the coordination compounds what we can understand, guys, this VBT, yes, helps us to understand, learn about bonding in coordination compounds. Okay, it helps us to learn about bonding in coordination compounds. Now we'll be learning few of the things over here. What it says that according to VBT, basically what it helps to understand. So what we can relate, valence bond theory in short form we can write VBT. So according to VBT, what you can relate over here, guys, yes, the metal or ion under the influence of ligands, or we can also consider side atoms, can use either n-1d orbital with ns and np nd orbitals, like these orbitals it can use for hybridization, okay, to yield a set of equivalent hybrid orbitals of definite geometry. So what we can relate that according to VBT, yes guys, what we can relate according to VBT, the metal atom or ion, right, the metal atom or ion under the influence of ligands, which is also we can relate. Hi Nitik, good evening. Under the influence of ligands, which we can also consider as side atoms, yes, can use n-1d, ns, np, nd orbitals for hybridization. Orbitals for what? Hybridization. Simple. Okay, and when it will undergo hybridization, what is going to happen? So to undergo hybridization, to yield a set of equivalent hybrid orbitals, of definite geometry. So no need to worry, guys, we won't be writing all those theoretical points over here that you can easily go through from your textbook. We are going to learn how to solve the question from valence bond theory, because within half an hour we can't learn the whole theory and all. But yes, from where the questions are asked from valence bond theory, that we are going to learn. So metal atom under the influence of ligands can use n minus 1d orbital, ns orbital, np orbital, nd orbital, any of them for hybridization to yield set of equivalent hybrid orbitals of definite geometry. Now talking about it, you know guys, everyone, yes, all of you must be knowing that the geometrical shape depends upon the hybridization. Yes or no? So depending upon what is the hybridization, can you get to know what will be the geometry? Yes or no? Tell me. Tell me, Netik, Abhishek, everyone. So hybridization, yes, depending upon that, can you tell the geometry? You must have learned that in the 11th standard, right? Hybridization, if it is SP, we used to say geometry can be linear, correct? If hybridization is SP2, we can say geometry is trigonal planar. So here, if, and remember, you have to also relate with steric number. Steric number, you can relate also with how many ligands are there or how many coordinate bonds are forming in it. Depending upon, you can answer in coordination compounds like 2, 3, 4. For steric number 4, you can have sp3 hybridization, and for that you can have what geometry, guys? You can have tetrahedral geometry. Yes, and you can have even, good evening Neetu, even you can have what? DSP2 hybridization as well. Even you can have DSP2 hybridization as well for the steric number 4 only, not 5. Remember, it's for the 4 only. Many of the students, they do mistake in this. They think that steric number is for 4 only. For 4, we have 2 hybridizations possible, sp3 and dsp2. We'll learn how you will get to know whether it's going to be sp3 or dsp2. For dsp2, it is going to be the geometry square planar. Okay. Talking about the next, if you have a steric number 5, you can have hybridization sp3d or dsp3. Anything you can relate. sp3d or dsp3. And for that, yes, what you can relate, you can call it as trigonal bipyramidal geometry. What you can call trigonal bipyramidal. Very good. Talking about the next one, you can have sp3d2 or d2sp3. Yes, both. If you have any hybridization, see, hybridizations are different, but for both of them geometry is same. That's why we are writing in this manner. Both will give you octahedral geometry only. Talking about the next, if you have a steric number 7, guys. So for steric number 7, very good Neetu. For steric number 7, do you know? Yes, so whether it's sp3 d3 or d3 sp3, you know what is the geometry? Yes, d3 sp3. It is pentagonal bipyramidal. Pentagonal bipyramidal, correct? Neetu, Netik, like here for sp3d, we call it as tbp, no? For d3 sp3 or sp3 d3, we call it as pbp in short form. BP is for not blood pressure, bipyramidal, and T signifies either trigonal or what? Pentagonal. Very good. So this is what we can relate. Depending on the steric number, depending upon the hybridization, we can tell the geometry. But how we will find out hybridization, that's the thing which VBT solved, and that's what we are going to learn. So guys, how to tell what will be the hybridization for any of the coordination complex? For that, I am going to tell you one series which is called as spectrochemical series. So guys, I'm telling you very important thing, that this spectrochemical series was not given in VBT. But to solve the questions of VBT easily, you should know this spectrochemical series, because if you will be knowing that, you can easily solve the questions, right? Regarding hybridization. So everyone, what is spectrochemical series? Spectrochemical series is a arrangement in which what we have done, we have arranged, yes, ligands according to their, yes, according to their strength. So it is an arrangement of ligands in the increasing order of their field strength, and that you call it as spectrochemical series. Correct? Netik, Neetu, everyone. What we can understand, spectrochemical series is very simple. It's an arrangement in which we have added the ligands, right? So in the increasing order of strength. So you have I negative, it is weak, Br negative, weak, thiocyanate, like You have its weak ligand, chlorine, sulfide, right? You have fluorine, they are weak ligand. I'll tell you from where it will start strong. Hydroxide, it's stronger than fluorine, right? Then you have oxalate, C2O4, 2 minus, water, NCS minus, isothiocyanate. See, this is thiocyanate, this is isothiocyanate. These all are ligands. Then you have EDTA. How many of you have heard about EDTA? It's a hexadentate ligand, ethylene diamine tetraacetate. Okay, so this is there, stronger one. Then NCS, obviously. Then you have NH3, EN, cyanide. You know what is EN? EN is ethylene diamine. It's a short form, right? For oxalate, you use a short form as OX. Ox is not like the bull, or that way you don't have to relate. Ox is oxalate ligand. EDTA is ethylene diamine. Rest, I hope everyone is able to relate. Ethylene, yes, not diamine. Ethylene diamine tetraacetate ion. So that is your EDTA. Then you have cyanide and CO. So what you can relate is, guys, that after NCS minus, you have all of these ligands, they are strong ligand. All the ligands after this, they are SFL, strong field ligands. They are strong ligands. Okay. While the before one, what you can relate, they are weak ligands. Now, in what oxidation state, how it works, we are going to learn that. But before, in general, we are learning that obviously in the starting of the spectrochemical series, they are weak ligands, and at the end when you are going, they are strong ligand. And out of that, strongest are like EDTA, amine, ethylene diamine, cyanide, and CO, carbonyl. So all those, they are very strong ligand, and above they are very weak ligands, right? Very good. So what we have to know here, let's just understand. Let's just do directly with one question only, that how you will find it out. The hybridization or geometry and many of the information regarding any coordination compound. Let's just play with question only for understanding this point. Okay, so we have one of the complex which we are learning, which is nothing but, say you have CO, NH3 6, cobalt, NH3 6 and 3 positive. This complex they will give, and they'll ask, yes, they will give you any complex. And what they'll give you, what type of question you get from BBT? They'll give you any complex and they'll ask, tell the hybridization, explain the hybridization. What? Explain the hybridization, geometrical shape, geometry, right? Magnetic moment, magnetic property, and nature of complex. So they'll ask you such type of questions, okay? And in MCQ questions also, they can ask any of the questions related. They can ask what? Any of the questions related, like they'll give you a complex and they'll ask any one thing or two things in the MCQ also. So what you will do first thing, whenever they give you any complex, you will find out what is the central metal. So obviously cobalt is going to be the central metal. So you know what is the oxidation state of cobalt? Tell me, Neetu, Netik, everyone. Amine is a neutral ligand. Everyone knows, right? Ammonia, amine is a neutral ligand. It doesn't have any charge. So if it is neutral ligand, so overall charge on the complex is due to the metal. So cobalt, if you write in general, normal configuration for it, its atomic number is what? Tell me. Its atomic number is iron, cobalt, nickel, 27. Argon, 4s2, 3d7. But here in the complex, guys, what is the oxidation state? +3. So you will remove obviously always the electron from 4s because this is the outermost shell, right? And then you will left with 3d6. So you can relate that. You have 3d. Fourth is the shell which comes after 3d, but in terms of energy we keep it before, right? So we have 3d6, then you have 4s, and then you have 4p, like that, so on. All things will be there because the moment electron enters in the fourth shell, you have s also, p also, d also, f also, everything is there. Here you have 3d. Now first what you will do, always you will write the configuration of the metal, Okay. In the ionic form, like what ion it is, what charge it is, you will write that, and then you will see what ligand is given to you. Okay. Next step is you have to check what ligand is given. So tell me what ligand is given. Amine. Amine is a strong ligand or weak ligand? Everyone tell me, Netek, Nitu. Amine is a strong ligand or weak ligand? Amine is a strong ligand. So if it is strong, tell me guys, if it is strong, so yes, what you can relate, if it is strong, you have to understand a very important thing. A strong ligands can do the pairing of electrons. Always remember, strong ligands undergo pairing of electrons, while weak ligands cannot undergo pairing of electrons. Here as a note, remember, strong ligands or strong field ligands can undergo pairing of electrons, while weak field ligands cannot undergo pairing of electrons. It's simple. This point, if you will relate, you will be easily able to answer it off. So what you can relate here, these two electrons and these two electrons will get paired because amine is a strong ligand. So what will happen in the 3D? It will get paired like the 6 electron which we were having. Because remember, tell me guys, it's very simple. Suppose if 6-7 students, they are sitting in a classroom, right? And if a small kid comes and tell that, oh, you all come and sit like two pairs and don't sit like alone, single bench. Are you going to, yes, are you going to take seriously this thing? If a small kid comes, right, 3rd, 4th student comes and tell you that, oh, you don't sit like this, you go and sit together in a pair, go. You will believe or you will take seriously? No. You won't go change your place. But suppose if a teacher or a principal comes and asks you to do that, can you refuse it? No. You will quickly go and change your places. Yes. Can you relate with it? So it's a very simple thing, guys. The strong things can make them to sit in one place. They can make them to get paired, and because of this reason, yes, what will happen? Pairing will take place. Now you have total how many ligands, guys? Tell me. Yes, you have total 6 ligands. So 6 ligands require 6 vacant orbitals for the 6 ligands requires 6 vacant orbitals for the donation. So now you have even this D also available. So what will happen? 2D, 1S and 3P will get involved, and it will be D2sp3 hybridization. The hybridization will be D2sp3. Depending upon how many ligands are there, that many orbitals you require, because every ligand will donate its 2 of the electron for the formation of bond. It's a coordinate bond. So because it was a strong ligand, it helped to do the pairing of electron, and because of that, these inner d orbitals are available for the bonding. So if it has D2sp3 hybridization, because when the moment I saw 6 ligands and they all were monodentate, I got to know string number is 6. It will be hybridization will be either sp3d2 or D2sp3. How will find it out whether it's sp3d2 or D2sp3? With the help of a ligand. Strength of a ligand. If it's a strong ligand, it will undergo pairing, and even inner d orbital can also participate. While if it's a weak ligand, it won't undergo pairing, so inner d orbital won't participate in the bonding. Simple. Okay, so D2sp3 hybridization you will get. Now if it is D2sp3 hybridization, geometry will be octahedral only. Very good. Now one more thing you can relate, that it is not having any unpaired electrons. So what will be its magnetic character? It is going to be diamagnetic. If you see in the configuration any unpaired electron, then you consider that as paramagnetic. If there is no unpaired electron, you consider that as, yes, you consider that as diamagnetic. I hope everyone is clear. Now, because here inner, yes, because here inner d shell is involved, so you can call it as inner orbital complex also. The nature of complex is, it is inner orbital complex. Correct guys, it is inner orbital complex, because here you have used inner d orbital, because here the inner d orbital is used for the hybridization. You can also call it as inner orbital complex. So these are the four information we have got: hybridization, geometry, magnetic character, and nature of complex. We have got all the information that they asked in the question. They asked hybridization, geometry, magnetic property, and nature of the complex. I hope everyone is able to relate. If you're able to relate, try to do this complex, guys. You will be easily able to do it. Now let's just practice, no? So you have COF6 3 plus. Now try to do it, guys. COF6 3 plus. Now again, fluorine contains -1 charge. So what is the charge on cobalt? Cobalt is, you know, a normal atomic number. It's 27. Argon 4s2 3d7. But cobalt here is in again +3 oxidation state. How you will find it out? X plus -1 into 6 is equal to +3. So X is +3. Yes, here like +3 is equal to, because it is -6 is equal to +3. So it has to be +3 charge or -3 charge, guys. It has to be -3 charge on the complex. Sometimes I give you a little different charge also. You have to relate. Correct? So it is not +3, it is -3 charge. 3 minus is given. So what will happen? 3 minus means you will relate. Here it is -3. So -3 plus 6. You will get +3 charge. Why? How I got to know that there is a mistake? Because cobalt generally make complexes in +3 oxidation state only. So by that also you can remember like these kind of things. This can help you to solve the question easily. So cobalt is in +3 oxidation state. Again it will be argon 4s0 3d6. So 3d6, right? But you have 4s 4p. Now after making this configuration, I will check fluorine is a strong ligand or weak ligand. Tell me everyone. Fluorine is a strong ligand or weak ligand? Fluorine is a weak ligand. So will it be able to do the pairing? No. No pairing. So 4s 4p, it requires 6. So where it will go? It will go to the 4d. So 1s 3p and 2d, here it will be used. So 1s p3 d2 will be the hybridization. So hybridization will be sp3d2. Geometry will be octahedral only. Magnetic character, because there are unpaired electron. How many unpaired electron? 4 unpaired electron. So it is paramagnetic character. If you have one unpaired electron also, still it is paramagnetic. More is the unpaired electron, more will be the paramagnetic character. And complex will be nature of complex, outer orbital. Remember, your outer orbital complex is also known as high spin or free spin complex. So as a note we can write outer orbital complex is also known as what? Is also known as high spin or spin free complex. Correct. And inner orbital complex is also known as what? Low spin complex. So inner orbital complex is also known as low spin complex. Low spin or spin paired or hyperligand complex. All are the names for it only. I hope everyone is able to relate. Very good. So let's just do some more questions. Let's see who and all will be able to answer it. So I'm giving you NiCl4 2 minus. So here there are 4 ligands. So for first steric number, you can have either sp3 or dsp2. That we have to judge what it is going to be. So Ni, what is the charge over here on the nickel? +2. So nickel normally it is argon 4s2 3d8. Ni +2 will be what? Ar 4s0 3d. Yes, Ar 4s0 3d. How much it is going to be? 8. Correct. 3d8 we can write. 4, 5, 6, 7, 8. Okay, then you have 4s and 4p. Now tell me guys, chlorine is a strong ligand or weak ligand? We can check. We should remember that chlorine is a weak ligand. So if chlorine is a weak ligand, what I can relate? Yes, it won't do pairing. So if it won't do pairing, I require 4. I will take sp3 only. So hybridization will be sp3 hybridization. Hybridization will be sp3 hybridization. Geometry will be tetrahedral. Yes, and the magnetic character will be paramagnetic because there is a unpaired electron. I hope everyone is able to relate with it. Tell me guys, yes or no? Very good. Do one more. If you have understood, do NiCN 4 2-, same way. We are just understanding the differences, right? Do NiCN 4 2-, everyone tell me what will be the difference here. NiCN 4 2-. Yeah, NiCN4 2-. So what you will do, again you will check nickel, argon 4s2 3d8, but here it is in +2 charge. You can relate, no, X is nickel, -1 into 4 is -1 charge is there on cyanide, there are 4 is equal to -2, so my X is equal to -2 plus 4, so it's +2. So nickel there is +2 charge. So argon you will first remove from 4s and then 3d8. So 3d8, 2, 3, 4, 5, 6, 7, 8, and you have 4s and 4p. You have 4 ligands, you require 4, but you have a cyanide ligand. So cyanide is a strong or weak ligand, guys? Again check. Cyanide is a strong ligand. So if it is a strong ligand, it will do pairing. So if it will do pairing, what is going to happen? These two electrons are going to sit together. 2, 3, 4, and like they are going to get paired, all of them. And here you have left with 1 here. So what will happen? 1D will get included here and you will do dsp2 hybridization. dsp2 hybridization, geometry will be square planar. Because inner d orbital is used, so it is inner orbital complex and it's going to be diamagnetic. Very good. So I hope everyone understood this concept regarding VBT. I just told you a simple way by which you can find it out. By which you can find it out what guys? The hybridization, geometry, magnetic properties and the nature of the complex easily. So that's what we have learned. I hope all of you have understood. Remember, you have to first see the complex, write the configuration of metal ion, and then after that you have to check ligand. If it's a strong ligand, it can do pairing. If it's a weak ligand, it cannot do pairing, and accordingly you will get the hybridization. I hope everyone is clear. Yes, very good guys. So make sure you're revising it, and if you get any doubt, do let me know in the next session. Okay guys, so if anyone is having any doubts and queries, you can ask. Otherwise, we'll be meeting in the next session. Thank you all of you. If you like the video, yes, make sure you are pressing the bell icon so that you will get the notification regarding the classes. And yes guys, we'll be meeting in the next session then. Thank you all of you. Bye bye. Thank you guys. Bye everyone.